So we have been dealing with systems of equations, and what we are going to do next is systems of inequalities. But we're not going to get into a true system of inequalities until Monday. Today we're just going to talk about how do we graph an inequality and look at our solution from that. So when we're talking about a linear inequality, it is like a linear equation, but it uses an inequality symbol. We have solved inequalities before. So when we talk about inequalities, what do those have in them? Instead of an equal sign, it has less than, greater than, less than or equal to, greater than or equal to. The big thing you have to remember with those, if you multiply or divide by a negative, what happens? The inequality flips. Otherwise, it's just like dealing with an equation. All right, so for example, with a linear inequality, we have ordered pairs that are solutions. So we solved inequalities with one variable, so we would have like x is greater than 4. And so any number greater than 4 was the solution. Now if we're looking at inequalities that have both x's and y's, it has to be that when we plug the ordered pair in, it makes the whole thing true. So let's check which of these would be a solution. To do that, we plug in this case, a 2 for the x, a 5 for the y, and we want to see if it's less than 15. You get 4 minus 15. Is negative 11 less than 15? Yes, negative 11 is smaller than 15, so this is true. So 2, 5 is an ordered pair that would be a solution to that inequality. All right, if I want to check if negative 1, 7 is a solution. So we plug in a negative 1 for the x, negative 7 for the y. Negative 2 plus 21. We get 19 less than 15. Is 19 less than 15? Right, it is greater than. So negative 1, 7, negative 7 would not be a solution to that inequality. You guys check the last two. See if they are. So if we check 3, negative 4, we get 6 plus 12. And 18 is not less than 15, so it is not a solution. If I check 0, 0. I get 0 is less than 15. Is 0 less than 15? Yes, so 0, 0 would be a solution. All right, so do you guys understand how to check if an ordered pair would be a solution or not? You just plug it in, see if you get a true statement. When we solve these, the solution is not just a single number. It is going to be a whole group of ordered pairs. And we can't really describe them all outside of drawing a graph. So our goal for these will just be to draw a graph to show the region that makes it true. To do this, we have to put our inequality in slope-intercept form. Just like you did yesterday with solving a system of equations on the graphing ones, you had to get it y equals mx plus b form so you could graph it. Still the same case here. We'll have to watch when we're doing that. If we have to multiply or divide by a negative, we flip our inequality just like before. We use a solid line if it's less than or equal to or greater than or equal to. So if it has an equal to, it gets a solid line. It will be a dashed line if it's just a less than or a greater than. So equal to is solid. If it doesn't have an equal to, we'll do dashed. Then we have to shade on our lines to decide which side of the line is part of our solution. Because it's not just going to be y equals something, it'll be y is greater than or y is less than. So we will shade above the line if it's greater than or equal to. We shade below the line if we have a less than or equal to. Alright, so now let's just solve one and see what happens. So first we're going to pretend like this were an equal to. If we want to graph it, we have to get the y by itself. So what would I do first? So negative 3y is less than negative 2x plus 15. Then what? And because it's an inequality, if we divide by a negative, flip the sign. So we get y is greater than 2/3 x minus 5. This is what we have to graph. So to graph that, we start at negative 5. Slope is 2/3, so up to over 3. Then we have to ask ourselves, will this be a solid or a dashed line? Dashed, because it doesn't have an equal to. So when I say a dashed line, you're using your ruler, but it's just dashed all the way across. Okay. Now we have to decide which ones to shade. So we want the y's to be greater than that. Greater than, is that above or below? Above. So we are going to shade in the area above this line. So what that means is any ordered pair in that shaded area is a solution. If, for instance, we put in a 0, 0, is 0, 0 in the shaded part? Yeah, it's in my shaded area. Let's plug it in. If I would have 0 is greater than negative 5. Is that true? Is 0 bigger than negative 5? Yes. So 0, 0 works. It's in the shaded region. If I took the point 5, negative 5, is that in my shaded region? No. If I put 5, negative 5 in here, so my y is negative 5. Okay, it's not pretty, but we get 10/3. Negative 5 is greater than 5/3, so 1.6 repeating. Is negative 5 bigger than that? No, it didn't work. So that's why that part isn't shaded. So any ordered pair where it is shaded works, and where it's not shaded does not. Does that make sense to everyone? Let's try another one. Alright, we're not going to do all of these, we'll do a few. So let's take a look at number 1. Actually, let's not do number 1. Let's do number 2. It's already in y equals mx plus b form. So we put a point at negative 1. My slope is negative 2. right one, or you could go up 2 and left 1. Then you have to ask yourself, am I using a solid or a dashed line? Solid. Why? This one has an equal to. So when you draw it, you get a solid line. Hopefully you're drawing a straighter line than I am. Then, we're not done. That's where y equals negative 2x minus 1. We have to shape. We wanted less than. So is less than above or below the line? Below. It's everything smaller. So we are shading under this line. Why don't you guys try number 4? Alright, so we subtract the x. Divide by negative 4. Because it's a negative, we flip the inequality. So we start at negative 2. Slope of 1/4, so up 1 over 4. Solid or dash? Dash, because it doesn't have an equal to. Above or below?
Above.
Greater than says above, so we're going to shade everything above this line. So any ordered pair in that shaded part would work. All right, let's look at 6. What would you do? So we have 2y is less than negative 3x. Divide by 2. So y is less than negative 3 halves x. How do you graph that?
I don't know.
Y-intercept is 0. Slope is negative 3/4. Negative 3 halves. So down 3, right 2. Or up 3 and left. Solid or dash?
And it's below.
Right, and then less than is below. Pretty good with these? Okay. I just want to mention something with 7 and 8. I want to touch on those real quick. They're not going to take very long, and then I'm done. If I look at problem 7, that doesn't have both an x and a y in it. What would I do? If it's x equals, it is vertical. Y equals is horizontal. So we have a horizontal line at negative 4. Because of the equal to, it would be solid. And then y is less than, so it would be above or below for shading. Below. Less than would be below. Alright, and number 8, x is greater than 7, so you would draw your line at positive 7. It is vertical and dash. Okay, our above and below rule doesn't really work here, but we can think about it. X is greater than 7, so the x's are bigger than 7.
To the right.
So that would be to the right.
Yeah.
Okay. Alright, we're doing pretty well with this. So let's just, how about we do the odd problems on this handout?
Yes.
I'm not going to make you do them all, just do the odd.